in space.
The Challenger disaster was an O-ring problem in the SRB that they launched under design temperatures. It was very, very cold, which is odd in Florida, but it was extremely cold.
And was it plagued by a bunch of delays coming up to that point in the first place?
It was. There were several launch scrubs, and we were getting beaten by the press pretty hard, and a lot of pressure was applied to NASA, and which I never understood. The newspapers and the press that kind of relied on people for their circulation. The press wasn't very kind to us, to be honest, in my opinion, and that added to the pressure to launch. And they launched when they were out of specification of the O-ring, suppleable. They weren't supple enough to contain the gases because the solid rocket boosters are stacked in segments, and they're bolted down in a way with an O-ring in between them to keep the gases in.
Right.
And that O-ring failed, and it burned into the tank and caused an explosion in the Challenger incident. And what had happened with the Columbia, there was a piece of external tank foam that broke loose from the tank and collided, with some of the RCC, the leading edge ablative that was on the leading edge of the wing, caused a big hole in that, and during a reentry, that led to a critical bleed through of hot gas from the reentry into the orbiter that caused that to break up, melted the aluminum in front of the left wheel well, actually, and caused a catastrophic breakup of Columbia. So the tile in itself, we've had a few burn-throughs of non-critical places that we were very fortunate, but it really did a good job. But the tile was something that was developed for the shuttle, a non-tested system that had to go through, and then that's a story in and of itself of a system that was designed, invented for the shuttle, and there were a lot of hurdles to overcome there.
Sure. I mean, just from the concept itself, I mean, re-entry into the atmosphere, belly first, it has to take insane amounts of heat, but also make sure that the crew inside was safe. I mean, that is not an easy feat to manage.
Exactly. And the vehicle's basically aluminum, titanium, or basically mostly aluminum, and to ablate that kind of heat was a feat in and of itself, really an engineering marvel of itself that was, and no one had experience in it, so it was developed kind of on the fly and learned on the fly,
and that's one of the more amazing parts after going back over this and reviewing the shuttle program. The fact that it was a 35, was it 30, 35 years? 30, how many years was it that it was in service, Jerry?
Well, it launched in 81 and
2011.
right. So,
Okay.
yeah, 30 years.
30 years.